Dear colleagues and friends, as acting president, I warmly welcome you to the technical meeting 2021 of GCRC, and we are just about to enter live session 1. The global production of oil crops is growing and currently amounts to almost 600 million metric tons. Leader is soybean with 361 million tons, followed by rapeseed, 69 million tons, and sunflower seed with 50 million tons. While the production of soybeans and sunflower was strongly extended recently, rapeseed cultivation has stagnated. In the European Union, in spite of climate change and current adverse weather conditions, the total oilseeds harvest in 2021 was expected to rise in comparison to last year. Record harvests were expected for soybeans and sunflower kernels, while the rapeseed harvest increased only moderately. The mean rapeseed yield in the European Union this year has been estimated on only 32 quintals per hectare, which is a low value, and a total harvest of 17 million tons, which equals to a quarter of world production. Reductions are probably due to limitations of nitrogen fertilization and availability of nitrogen, as well as restrictions of chemical plant protection, along with susceptibility of rapeseed cultivars to pests and stresses, and pathogens particularly. In view of long-term perspectives, intense breeding efforts for improving nitrogen efficiency and pest resistance are urgently needed. This serious situation for cultivation of oilseed rape all over the world deserves our continued activity for improving future rapeseed cultivars for disease and pest resistance, as well as enhanced tolerance to environment stress. The need for scientific research and development in this area is very obvious. Therefore, insect pest management has been chosen as one of the 2 major topics of this conference. This current session has been most competently organized and prepared by our colleague Sam Cook from Rothamsted. Improvements on the side of production need to be met by continued efforts in improving seed quality by breeding and processing. Canola and rapeseed oil today is known and highly estimated for its outstanding food quality and value as a feedstuff for biodiesel production. Additional value could be added to canola meal by improving rapeseed protein, not only as an animal feed, but also as a basis for valuable plant-based protein food for human consumption. For that reason, rapeseed protein is the second major topic of this meeting. As an expert in this field and above, our colleague Veronique Batté from the Canadian Grain Commission Winnipeg has been kind enough to design and organize this session. Along with positive price trends for oil crops, vegetable oils, and oil meal, the competitiveness of oil plants is expected to increase further. This trend will be highly welcome in the sense of widening crop rotations and increasing biodiversity in arable fields and agriculture as a whole. Above all, we very much appreciate the readiness of our estimated colleague Ivona Bartkowiak-Broda to really hold this technical meeting physically in Poznan. It is, of course, highly undesirable that this could not be realized due to well-known reasons. Poland and Poznan in particular are very attractive locations to visit and to get to know. Furthermore, Poland is a major player in rapeseed research, development, and cultivation, as well as use. Therefore, it is really a pity that we cannot meet there in person now, and I very much hope to catch up as soon as possible. The alternative video conference, which we are attending right now, has been very well organized by Ivona and her group, technically aided by Michael Oszowski and the lively team. thank you and the GCRC Secretariat for doing an excellent job. We are looking forward to a fruitful meeting with high-class contributions and stimulating discussions. And I wish you a profitable conference. Thanks very much.
Thank you very much, Wolfgang, for that wonderful introduction. And thank you very much to the Global Council for Innovation in Rapeseed and Canola for inviting a whole session on insect pests in rapeseed. I'm really delighted to be asked to organise this programme, and thank you very much to all the speakers for joining in. So what I'd like to do is try to share my screen with you so that I can give you a quick update on everybody's presentations. I hope that all of you listening have managed to look at all the presentations. Just to let you know that they'll be online and you'll have access to them for 3 months. So if you haven't yet done so, please do go back and have another look. I'll give you a quick update on what was said. We'd like to have a session, a question and answer session for the speakers, and then followed by a short discussion. So here we go. I'm going to try and share my screen with you. So welcome to the live Insect Pest Management in Rapeseed technical meeting. And we'd like to discuss how we can move towards sustainable control in insect pest management. So here's a very brief summary of everybody's wonderful presentations that we've just heard. I'd like to thank Wolfgang for his excellent introduction and pull out a quote that he said, that vegetable oilseed rape has stagnated, mainly due to issues regarding nitrogen fertilization and susceptibility of insect pests. And this is why we're here right now. Our first speaker was Dr. Sabine Andert, and she was talking about the farmers' perspectives of future management in winter oilseed rape. And there was a very clear trend that growers were starting to stop growing oilseed rape and reduce the cropping, mainly due to insect pests in autumn, which was the #1 reason of farmers that responded, and spring pests, which was the #2 reason for a decline in oilseed rape by these farmers. They thought that they were going to increase the rotation, which, you know, I'd like to come back to maybe in the discussion, because maybe that has problems for biodiversity, and that turnips yellows virus weren't a problem. So we clearly have a problem with insect pests. So what can we do about it? And is integrated pest management the answer? So I asked a wonderful bunch of people from all over the major rapeseed growing areas of the globe to tell us about the main pests in each of the regions and the control situations that each of those regions are facing, and maybe what are the main alternative control options available in these countries. And we heard from Dr. Serena McFadden, Dr. Boyd Morey, Mika Brandes, Sawen Kumar, and Shimin Hu, who told us about Australia, Canada, Europe, India, and China. And it was clear that insect rapeseed pests are really diverse, and different regions suffer different pest problems, which we might imagine due to the different climatic and cropping practices. But interestingly, Mika Brandes really showed very clearly that even within a region, different countries have very different problems. And this makes management of the pests within the crop really difficult. It was clear that all regions have a very high reliance on insecticides, particularly these broad spectrum insecticides that are cheap. And by this mainly is the pyrethroid insecticides. And I think this is mainly why we're starting to see the problems with pests that we have because of widespread resistance in some of those regions, particularly where those regions are reliant on maybe 1 or 2 active ingredients. I thought it was really interesting that there was a couple of mentions of new pests. Maybe these are emerging as a result of widespread resistance, or maybe they are emerging because we're actually looking at the crop a bit more. But Serena mentioned earwigs, and I know Boyd and his team have identified a new species of midge that's a problem in Canada. Everybody mentioned that agronomic practices for pest reduction are available, and they're actually quite common. Early sowing being a particular strategy, that farmers are sowing their crops early in particular way to try to avoid pest infestation. It was interesting that only a handful of commercially available alternatives to insecticides are available, and maybe this is a really important point for a conversation and discussion and future research. But on the wish list of every country was a wish for culture resistant cultivars, and this is what Maxime Hervé talked about in his session. He said that developing insect resistance cultivars is very challenging, and that's probably why we haven't got any yet. Several approaches have been tried: transgenes, protein inhibitors, lectins. Hairy canola has been the most successful, but we still haven't got commercial varieties of that strategy available to us. Maybe resistance in Brassica napus. Let's screen the available genotypes, the genetic variation that we do have. There's been some success for that with stem weevils, pollen beetles, aphid, cabbage root fly, and there's actually quite a lot of ongoing work across Europe in particular to find resistant varieties for cabbage stem flea beetle. But there's quite a long way to go on that, and Maxim believed that perhaps it was a mission impossible. Resynthesized lines, where we're breeding two types of brassicas, may be an alternative strategy or a solution to this problem, but possibly the best strategy so far is to integress lines, and Sinapis alba seems to be resistant to most of the pests tested, so maybe here is a real hope for the future. Maxim ended by saying that diversity is needed, especially including within field and crop diversity strategies, which goes quite nicely with what Céline Robert from Terra Zenobia was talking about in her talk in the agronomy committee. She was talking about different strategies that farmers can grow for agronomical methods for insect pest suppression. Farmers can try to avoid the problem in the first place by companion planting. This is a really interesting piece of research, planting different frost-sensitive legumes to help the crop grow past its early susceptible stage. Farmers are also sowing early. They're showing early tillage, maybe to preserve moisture in the field. Plant tolerance is really important. Maybe these frost-sensitive legumes are giving the plant some extra nutrition, and this is helping the biomass of those plants to increase. Celine and her team found that the increased biomass of oilseed rape led to less damage when plants had more biomass. Early vigor was important. Robust plants that grow through the winter and then can get going again in the spring was really important. And there was difference between cultivars. So this goes back to what Maxime was saying, that maybe there's not that much variation between cultivars, but perhaps actually there is. So maybe there is some hope for tolerance, if not resistance. She presented a really interesting, innovative agroecological system, which included a 9-year rotation with barley or durum wheat as a preceding crop, direct seeding, deep non-inversion tilling, the use of these cover crops and companion planting with legumes, and found that these systems could increase the biomass of the plant, increase yield, increase the profit margin of the farmer, and reduce the availability, the use of insecticides, which was just awesome. So really, we do see a strong potential for these agronomical methods to suppress insect pests. And Celine's parting comment was that there is great potential for beneficial insects via habitat and landscape management, which leads into Hector's talk. But before then, I want to talk about Sandra Lindstrom's wonderful presentation, and I think she wins the prize for the best speaker picture. She looked at the effect of bees and pollination on yield and quality of rapeseed. And interestingly, pollination is not currently considered as an agronomic planning process due to the lack of studies on pollination. Most rapeseed cultivars are wind pollinated, and I think that's, you know, the effect of pollination has very much been neglected. She reviewed the literature on this and found that pollination in oilseed rape can increase the soil content by 2% in spring cultivars and 7% in winter cultivars. Who would not want that? Also, pollination increased seed yield by 10 to 50%, depending on, you know, what literature you look at. And in her own studies, she found a yield effect which depended on crop cultivar. Open pollinated cultivars responded better than hybrids, as you can possibly imagine that would be the case. And actually she supported some of my own research that showed that genetically GMS, genetic male sterility, produce more nectar than cytoplasmic male sterility hybrids and open pollinated hybrids. So maybe there's some possibilities there to manipulate or to improve the value of the oilseed rape crop for pollinating and flower visiting insects. Lastly, she found that insecticides could actually increase yield due to improved pollination. So insecticide use, because the bees maybe don't like damaged flowers, produced more flowers, more nectar per flower. There were more pollinators and less pollinator visits without nectar foraging. So nectar insecticide use could actually increase yield due to improved pollination, not necessarily due to improved pest regulation. And I love that concept. So I think we could think about that some more. And her parting comment was that we need insecticides that don't directly harm pollinators. So again, that thought leads really nicely into the alternatives that are coming now through the research pipeline. Hector Carcamo really nicely presented some classical biological control research, trying to control a cabbage seed pod weevil by Trichomelus perfectus and the Lygus bug with another parasitoid that was present in America. Trichomelus perfectus is actually an introduced species, but it has established itself in Canada. And the other parasitoid is there's a native species and also a species that's come from America. And he's looking very closely at the safety requirements. Can we release these species into Canada without causing problems on the native insects? And will they establish and do the job well? Dr. Perrin, Scott Ross looked at harnessing endosymbiotic bacteria in aphids for crop protection. So aphids have bugs within them, which mostly do them good, but some of them do them harm. And he found that there's a diverse range of endosymbiotics with positive and negative effects, which then can then be manipulated for pest management. We could add them to insects, or we can knock them out by use of antibiotics. And for an example, he really showed that this Rixiella causes color changes, which might influence natural enemy behavior. But this Buccarina is essential, and without it, insects, the aphids, become infertile. So there's some really nice potential for future control strategies here. And lastly, we've got RNAi, the technology that silences genes. Eve Veerman and her team have very nicely shown the possibility for this in pollen beetles, developing an RNAi approach, which is based on the Cotamer protein, alpha COP, using microinjection and sucrose nectar feeding bioassays. They showed that they could kill 100% of pollen beetles that were tested. However, when the RNAi dsRNA was applied to the buds, which kind of mimics what you would do if you sprayed the crop with this gene silencing technology, there was less mortality, but it was still good. And I think growers would take that level of control. Interestingly, they showed that simulated chronic feeding, so they applied it to the anthers and then they let the beetles feed on it again and again and again. That simulates a GM approach, and they found that the beetles died faster than if it was sprayed onto the outside of the bud. So a genetic gene approach in a plant would perform better than a sprayed approach, but actually both approaches, show real promise. And last but not least, Guy Schmeger looked at the registration process of RNAi, and it's extremely difficult to understand and complicated, and actually changes a lot between the USA, Europe, and the rest of the world, and especially Australia and New Zealand. It depends how we view RNAi technology, as biochemicals, as pesticides, or just other natural products. And I think that's it. Yes, so that was a very, very brief overview of what our speakers spoke about. I'd like to now open the question and answer session for speakers. So you've posed several questions in the pre-recorded chat section, which I have harvested, and we'll go through that one by one and give those questions to the speakers. Please do continue to ask your questions through the live chat function. And now that we're on Zoom, we also have the function, if you raise your hand, we can switch your microphone on and we could actually ask your question live if you prefer to do that. Then we'll go to a discussion with a panel of the speakers, but I would love to have your input as well. So again, raise your hand and butt in. And I'd like to kind of try to address some questions. Is a lack of synthetic active ingredients driving the pest problems that we see across the globe due to resistance issues? Can we grow oilseed rape without insecticides? What tools have we got now? We've seen that in our presentation. But what of those are most likely to enable us to grow rapeseed without insecticides? And what are the main barriers to achieving sustainable production at the moment? So with that, I'll try to stop sharing and I will go back to the live meeting. Can you not see my screen now? Can somebody say yes or no?
Yes.
Great. Okay, so we'll open the live session. Please, I'm looking at the chat, and so is Professor Andreas van Tiedemann. I'd just like to say thank you very much for agreeing to be my co-moderator, my co-pilot today. Thank you to everybody for joining in, and I'll open the questions for speakers. We'll start with Sabine Andert. Are you here?
Yes, I am here.
Hi there.
Hi.
Right, so if anyone's got a question, particularly for Sabine, if you'd like to write it in the chat now, that would be great. And in the meantime, I'd like to kick off, if I may. I was really interested in the comment that you made about the longer rotations. So farmers are going to reduce the amount of oilseed rape they grow. They're going to do this mainly by increasing the length of the rotation. And I'd like to ask you if you think that this will reduce the incidence of pests that we're seeing. And then I'd also like to ask you about the fact that a lot of them are not going to replace oilseed rape in the rotation with other flowering crops. They're going to reduce them with spring barley, oats and other cereals, which obviously isn't going to be quite such a good thing for bees. So I'm just wondering what you think the effect will be of these longer rotations on bees and pollination. Can we start with that, please?
Yes, many thanks for your questions. Yeah, one of our most interesting results of our farmers case study was that farmers anticipated to grow a smaller share of winter oilseed rape in the future with a 1 year longer rotation gap. And unfortunately, as an alternative crop, farmers, participants foreseen to increase maize and winter cereal cropping in northern Germany. So no real flowers for insects. And the most important factor for the decrease in winter oilseed rape for the northern German farmers was the insect pests in autumn and spring, and therefore they will probably decrease their winter oilseed rape cropping.
Sabine, are you able to switch your camera on?
No, I'm not able.
Okay, that's all right.
I don't know why.
Okay.
So that's a mistake. Sorry for this.
No, that's okay.
Can anyone help me? I tested it before and yeah. Okay, start my video.
I guess you switched it on, right? Camera switched on?
Yeah, it is, yeah.
Never mind.
Sorry for this.
No worries. Okay. And can I ask if another question?
Yeah.
There are two hands up, huh?
That the turnips yellows virus, farmers didn't consider this to be a very big problem, or it's not a reason why they're considering giving up oilseed rape. And I wonder if that's because, do you think that's because of the availability of cultivars that are resistant to turnips yellows virus, or do you just think that they're, you know, it's not a problem for them?
Yeah, it was a huge surprise for us too. So we expected that it is a huge problem for the farmers. However, North German farmers participants considered the turnip yellow resistant cultivars as an effective tool, and therefore they are worry less about the influence of the turnip yellow virus infestation for future winter oilseed rape cropping. And our farmers are mostly, a huge part of the farmers in Mecklenburg-Vorpommern are currently using the turnip yellow virus resistant cultivars yet.
Okay, thanks. Wolfgang, I can see you've got your hand up.
Yes, please, thank you. A brief question. You have done a very interesting field study, I think, with 90 farms, but the size of the farms is very large. So the average was 1,200 hectares, which is of course very large in comparison to West Germany. My question is whether this would affect the results. What do you think? I mean, in comparison to other situations where you have smaller farms.
Yeah, so at first we were lucky about the high number of respondents of the farmers, and the more than 100,000 hectares represents approximately 10% of the arable land in the federal state Mecklenburg-Vorpommern. So in my opinion, our farmer questionnaire is quite representative. And yeah, regarding your questions, for sure, the farms in Mecklenburg, Western Pomerania or have high arable land sizes, and especially the percentage of winter oilseed rape is quite high, especially compared to other regions in Germany. And therefore, I'm not sure if our conclusions that the share of winter oilseed rape will decrease for future cropping is the same for regions with a smaller overall share of winter oilseed rape. However, for sure, currently high level of winter oilseed rape cropping, as in our case study, we assume that the overall share of winter oilseed rape will decrease.
Thank you.
Andreas, have you got your hand up? Professor von Tiedemann.
Yeah, yes, thanks, Sam. Thanks, Sabine Andert, for the interesting study. you were identifying that insect pests in autumn and springtime are a major constraint in oilseed rape production in Germany, as something we should all know. It's in other countries it's the same. But I wonder why one of the reaction on that is that farmers would widen their crop rotation from 3 to 4 years, because I'm really in doubt that this would help in any way to solve that problem. So once you are growing enough oilseed rape fields in a region, you will allow pests to perform the life cycles in the region on the landscape level, as we know, because they are roaming around, they are mobile. So there's no results showing that this would help against the pest problem. So why are farmers widening their rotation in the light of this problem?
Yeah, many thanks. Beside insect pests in autumn and spring, our farmers gave more answers regarding main reasons of influence for decline in winter oilseed rape cropping. And there are other main reasons, for example, weather conditions, and especially in German, they are new fertilizer audience amendment, and especially in Mecklenburg-Vorpommern with high share of winter oilseed rape and crop rotation, clapwood as a main reason for future decrease in winter oilseed rape. So again, for this reason, with a very high share of winter oilseed rape and reason, the main reason for decrease in winter oilseed rape are insect pests from the perspective of farmers. However, clapwood or weather extremes or the nitrogen fertilizer use are also main reasons for the farmers to probably decline their oilseed rape cropping.
But the farmers are aware that they are not managing their pests with that. They may improve on pathogen control. Maybe clapwood might be a responsive pathogen, but not the pest. They are aware of that?
I'm not sure about it. It's a good question.
They should be advised, I guess. Yeah. So that's not the solution, I guess, unfortunately.
Yeah.
Sorry, we've got a comment. I can't see who the comment's from. I'm sorry. There's just a comment here. I think it's following up that point. The farmers may not be reducing intensity to fix the insects. That they do it because other crops are more profitable. Yeah.
Yeah. Probably other crops are not more profitable. Profitable. However, they are more manageable for the farmers, and that's a main reason for the farmers.
Yeah. Rona, you've got your hand up.
Yeah. Yeah. Do you hear me?
Yes. Yes.
I think it's this presentation was very interesting for me, because I think that this problem with bees is increased in last years, because last years and also this year I had informations from beekeepers. They asked me what happened, because they found that the bees don't like visit the fields with rapeseed so much as earlier, and the yield of honey is also lower. They suppose that it is due to the new varieties, new types of varieties. They didn't think that maybe it is the problem of pests on bees. So it's really, for me, it was also difficult to explain them, but this research is really complete, and it can help me also to discuss with our beekeepers in Poland. Thank you very much.
Many thanks.
Just to go back to that question about bees, we've had that similar question from beekeepers as well. They're moaning that their honey yields have gone down, and they said, oh, it's because of these newfangled, hybrid varieties, which is what stimulated our research on the pollen and nectar availability and how that varied across different types of oilseed rape cultivars. And this goes really for also Sandra Lindstrom's work as well, that the new hybrid varieties, actually we showed that they had more nectar in than the conventional open pollinated varieties. I don't know if you want to jump in here, Sandra, but obviously that's not the reason why the honey yields are declining. Do you want to say anything more about that?
Well, not really. I have experienced that from Sweden. I've heard this from several beekeepers the last 5 or 6 years. But as you said, Samantha, we have also done nectar studies here using the most common cultivars on the market, and we haven't seen a decrease in nectar production in the newer cultivars at all.
So that's not the reason for the yield declines.
No, it must be something else.
Yeah. Okay, so Pankaj Sharma, we've got your hand is up. Would you like to ask a question? Dr. Sharma, is your question up? Apparently your hand is raised. Hi. You're muted if you want to ask your question.
Yeah, I'm audible.
Yeah, we can hear you.
Greetings to all panelists, Dr. Wolfgang Figit, Andrew Tagman, and all the panelists. Greetings to all. Have a nice, wonderful organization of GCIRC technical meeting. And we were there in the last group discussions with Samantha. My opinion regarding what do you think about the new nicotinoids, insecticides for the pollinators? What you have planned, that how much these nicotinoids, insecticides will be there in the management of insect, particularly mustard aphid or rapeseed aphid?
Shall we leave that question for the crop protection, or do you want to address that question to the bit? I think that question should probably go to somebody like Micah Brandes, actually. So can we hold that question for the next few speakers? Thanks for that. It's a good one.
Thank you.
It's a good question. So with that, then if anybody's got any more questions for Sabine and Dirk, then please do shout now. We can always come back to it once we've started to think about that. But I'd like to start, questions for the next group of speakers, which basically spoke about crop protection. So maybe if I'm not sure if I can see Micah Brandes, are you there? No. Okay. So let me just look at my list. Sorry. That could have helped. Well, to answer that question myself, I guess in Europe we're not allowed to use neonicotinoid seed treatments unless there's been a derogation. So there was an interesting example actually of a wonderful IPM in action in the UK for sugar beet, and the UK government allowed the neonicotinoid seed treatments on sugar beet to happen only if aphid prediction models showed that the aphids would land on the crop at the damage susceptible time. The models are produced by Rothamsted Insect Survey, and they actually predicted that because of the cold winter, we wouldn't have a very large or particularly they wouldn't have an early migration of the aphids. So the derogation was not permitted. So growers were not permitted to grow oilseed rape with neonicotinoid seed, sugar beet with neonicotinoid seed treatments. And the decision was the right one because the aphids were very, very late and it wasn't needed. I think if we could move to that kind of model for aphids and other pests of oilseed rape, then we could use the neonicotinoid seed treatments a little bit more judiciously than we currently are. So if your question, Dr. Sharma, was about, can we use them in Europe, then no, not really. But maybe I'll just pass over to Boyd Morey on that, because you use a lot of neonicotinoid insecticides over there in Canada, don't you? And is it useful for aphids?
So yeah, we use a lot of neonicotinoid seed treatments. We don't really have many issues with aphids in our canola though. And so by the time we would have any, if we potentially had aphid issues, it's usually very late in the season where the seed treatment has already worn off. We have no foliar neonicotinoids available. So that's really not something that we consider with our neonics here, at least in terms of aphids.
Okay. There was another question for you, Boyd, about more resistant swede midge. So it was a really interesting question from Krista Pearson. He was talking, he made quite a long comment about the phenology of flowering and the phenology of crops in terms of escape from avoidance. And he was thinking about in Canada with the spring canolas that are sown there, winter canola seems to be more resistant to swede midge. And what's the prospect that the winter crops could be moved further north? Maybe some more winter tolerant varieties could be found. Do you think it's possible to grow more winter canola varieties and therefore escape problems with swede midge?
I was just attempting to answer that question in the chat, but that is a good question. To date, there has been a little bit of work with winter varieties on the Canadian prairies, which of course is our major canola growing region. But basically nothing survives. So winter hardiness would really need to be increased dramatically to survive our cold temperatures. In Ontario and Quebec, kind of definitely a lot more southern, a lot more moderate climate, winter canola acreage is increasing, but it's still pretty minor crop in that region. Big if winter hardiness could be increased, I believe it might be possible to fit in rotation with some of our current crops. We do have winter wheat, which is often considered for us, again, a very southern prairie crop, but it is expanding its range with increased breeding. And so producers, farmers are starting to grow it even as far north as Peace River, which is, our very northern growing region here in Canada. So there is potential, but it would take a lot of trial and effort and a lot of, I guess, there would have to be a really big incentive for farmers to actually grow it.
What does it yield like in terms of winter versus spring?
That is a good question, Sam. I know I actually looked this up the other day because I always thought winter canola yielded a lot more. When I was looking at a work from Ontario just the other day, it wasn't that much more. It was, I think, like 5 to 10. Well, I guess it could be quite a bit. 5 to 10 bushels an acre more than spring type. But maybe someone, if Clinton, you're someone else they might have better numbers than that than I do. But there is a bit of a yield increase, but to me, it wasn't as dramatic as I thought it was going to be.
Okay, thanks. Andreas, you had your hand up. I'm sorry. Is it?
I just wanted to let the discussion go, but I have a question to Serena McFadyen. I was surprised to see so many new pests in your country, with some interesting species like European earwig, which is known in Germany and Europe as a pest in grapes, actually. So it's really interesting to see it in oilseed rape. So I would like to turn around the question posed by Sam. Is the lack of active ingredients driving pest problem? Let's turn it around by asking if a comfortable situation having many insecticides driving the income of new species, perhaps because they eradicate the traditional ones. Is that a theory which could hold, or what do you think? What are the reasons for it?
Can you hear me all right, everyone?
Yes, we can.
Yeah.
Yep, great. That's a really good question. I mean, we do have a lot of availability of different actives within the Australian southern grains production systems, both seed dressings as well as other foliar sprays. Obviously, there are some producers that think that there's not enough tools in the toolbox, but actually, when you look globally, we do have quite a good scope. I don't think some of these new pests are actually due to insecticide use patterns. I think some of them are mainly due to agronomic practice change across many years. So we've had European earwigs in our systems for many, many years. They're just only now becoming a pest. And some of these pests, particularly detritivores and the omnivores, you know, they're very hard to manage because some of them, I mean, European earwig's a good example. In canola, we don't have registered pesticides to control it. And even if you did, I don't think they'd be that effective. So it's really a relationship between how you're changing that farm environment as a resource for detritivores and omnivores more generally, around stubble management, around changing our sowing patterns, and then how those rotation systems keep biomass on the field throughout the whole year. And that's more of an issue for these types of pests than some of the other more traditional pests that we would see, like our mites, lucerne flea, aphids, lepidopterans, which are more about that, you know, the above ground biomass and how it's functioning. So if I understand your question correctly, I don't think they're causing new issues. The key problem though around insecticides is that there is a chance that European earwigs already have resistance, because even though there's nothing registered for them, they're in the field the whole year, and so they get exposed to a lot of insecticide application. So my concern is if they're now becoming a pest and they're moving from a beneficial category into a pest, and then they get a decent level of resistance, you know, you've really created a problem for yourself that potentially we could have avoided if we'd done some other management strategies early on. And there is a table that sort of shows the propensity of different species, at least theoretically, to develop resistance. And actually European earwig is relatively high, given that it's, you know, it's not targeted generally. It shouldn't really have any targeted sprays, but because it gets so many non-target applications, you know, it's at risk. And I think that's the key issue for me anyway in these systems is, what are the problems we're creating that we're not focusing on because they're not a problem now, but in 10 years time, we're going to look back and say, well, you know, it was only a really minor pest back then, but now it's got resistance and it's a much bigger issue in terms of the practices that we're using in when we're planting and stuff. Does that sort of answer your question?
Yeah, thanks. It's very interesting. So they are resistant, yeah? So once you expose them to insecticides, they are resistant? Is that so? Against
we don't have any evidence.
You don't have the evidence.
Yeah, we don't have evidence. We just theoretically think that because they, in theory, have, we've not tested, but it wouldn't surprise me if they were. We had a few resistant populations because it hasn't been tested, and they just get exposed to so many applications throughout the year that it would be highly likely, even though they're not, you know, they have a long life cycle, you know, they're not like an aphid that has a very short life cycle and so therefore has much bigger risk. So yeah, but no, we don't have any evidence. We have pretty limited resistance testing. We do resistance testing in projects on specific species, but we don't have a coordinated approach to resistance monitoring across our invertebrate pest species.
But that would mean that even a broad range of different modes of action used with insecticides, which you have at hand, they cannot avoid the formation of this kind of resistance. It's a multiple resistance then, huh? Isn't it? It
No,
could also
well, I
happen
think
with
there's a,
pests.
yeah, and I think there is a lot of things going on where we talk about the numbers of modes of action, but you know, the numbers of mode of action versus what's actually used each year are very different in the field. So if there's a couple of modes that are really popular because the products are very cheap, they'll get used more frequently. So even if your toolbox has 5 modes of action, you may only use 2 of those each year. And if that's used very frequently, then you know, it's likely that you're going to get resistance. The second aspect is that we do have resistance management plans for a number of our invertebrate pests, not just for canola, but also pests in grains. And we don't really understand if they're used, what's the compliance rate, how many people within a region would have to take up that resistance management plan in order for it to work. And then the third aspect is we haven't, you know, because we don't have some understanding of how much compliance, we can't say whether those resistance management plans are scientifically sound. We don't have a strong evidence to say if you implement this plan, you will delay the development of resistance in that species, because we've really just said it's rotating chemicals, trying alternatives. We haven't really, as researchers, had an opportunity to look back and say, did that resistance management plan actually deliver what we thought it would? Because it's kind of like a landscape scale experiment that we don't often get a chance to actually assess. So I suppose those are the 3 aspects that I think are quite important in our system to try to understand anyway.
Okay, thanks a lot.
So that, I think that well, there's several strands we could follow with that question. But maybe that about the alternatives, maybe that links with Martin Frown's question to you, Serena. Who he said, thanks for a nice Australian overview. You mentioned intercropping as a future option for pest control. Do you have any ideas what species could be used? Because obviously if intercropping worked really well, then you wouldn't need quite so many pesticide applications in the first place. But it's easier said than done, right?
Yeah, it's a really good question, and we'd love to do a lot more work to actually optimize an intercropping rotation that includes an intercrop of canola with something else. Obviously, some of the historical work that's been done that's shown really good benefits in terms of nitrogen and insect pest management, it involves a maize intercrop, and that's not suitable for these systems. So some of the legumes that were mentioned in the presentation are really where I think we're going to have to go. I think one of the advantages for Australia is that a lot of producers have adopted quite controlled traffic technology to sow, so they can be very precise on their sowing. So you've got a lot of options because you've got such an ability to control where you seed, when. So it's just a matter of going through the potential options and understanding which ones can have benefits. And it'll work, it'll be adopted if it doesn't just have benefits for insects, but also for pathogens and for weeds. If you can get something that provides benefits across the board for all those different categories, even if it's only a small benefit, it'll be pretty readily adopted, I suspect. But yeah, we still need to do some research to figure out what exactly is the optimal solution, especially for minimising or optimising water use between the 2 crops.
Excellent answer. Robert, sorry, you've got your hand raised, and welcome. Can you ask your question, Robert Wilson?
Thanks, Sam. Serena, just with the changing of and getting earlier planting dates, what impact do you think that will have, and certainly with more stubble retention, particularly in the eastern part of Australia, what impact do you think that could have with insects going forward?
The biggest issue there is for aphids and the diseases they vector. So the later the sowing, the greater chance you have of having aphid flights that then go down into a quiet or senescing period. So they don't actually have much population growth or movement. Whereas the earlier you have it, if you have a warm spell at the time of sowing and the time of crop germination, I think your biggest risk is to increase aphid outbreaks and virus outbreaks. And that's what we sort of see when we have a green bridge followed by a close early sowing. And that's really where the risk lies. In some ways, we've got seed dressings that can help with that, but also they do wear off, and some of them aren't as effective for certain species versus others. So there's still a lot of work to be done to make sure that seed dressings actually provide all the benefits that they could. And then the stubble management is a slight, we have a small study that suggests that if you have stubble that's higher than the germinating canola crop, that it does reduce aphid landing on the green canola plants, but it's a very small study. I'm not 100% certain that it's enough to really say that if your stubble height is higher than the germinating, then you'll actually reduce aphid transmission of viruses. So yeah, that's my key concern is around early aphid outbreaks.
Okay, thanks for that question. Yeah, with the stubbles, actually, there's a very small study on stubble management against cabbage stem flea beetle, and it's shown that long stubbles reduce landing of flea beetles. Maybe this is something Celine Robert would like to pick up in her session. But yeah, I think there's definitely something in those kind of techniques. I'd like to try to get back to the insecticide issue. Maybe now we've got Micah Branders. You're back in, are you? Yes, brilliant. I'm sorry if you could hear us and not get in about that question about neonicotinoids. I don't know if you can say something about that question, but I want to ask you, based on what Serena was just talking about in terms of, you know, resistance monitoring, how important it is really, and you know, your resistance monitoring program in Germany is almost second to none. How can we improve resistance monitoring strategies kind of outside of Europe? How would you recommend that other countries, you know, implement resistance monitoring strategies, because you've been so successful in yours? I think that's the first step. You know, you need them before you can, you know, evaluate whether or not they work or not. And certainly, you know, in Sarwan Kumar has commented that, you know, they don't have strategies like that in India. So how would they implement them? If you could turn your camera on, if you've got one, that would be superb as well. Micah? I've just asked that big question. She's not there. She's there, but she's not there. Maybe she's just gone for a cup of tea. Okay, we'll come back. We'll come back to Micah. Well, okay, let's go to Sarwan Kumar next. Are you there? I think I saw. Yes, Sarwan, you're there. You made the point that there are no resistance strategy monitoring strategies in India. I don't know if you want to say something about that first before we move on. Can you unmute yourself?
Okay. Is it all right now?
Yep, great.
Thanks, Sam. In India, actually, the pest problems start from the mid of January. So here, the main thing is that the farmers, they should be more vigilant. They are vigilant for monitoring of their crop, for particularly aphids are the most serious pests in India. And whenever the aphids, they reach economic threshold level, action threshold level, so they go for a spray of insecticide, or if the populations are low, then they simply pluck those twigs and destroy them. Dr. Pankaj Sharma has told that neonics, if they are banned, then do we have any alternatives? So in India, we do have alternatives, chlorpyrifos and dimethoate. They are still effective. Neonics, only one insecticide, thiamethoxam, is registered for this, and others like imidacloprid, they are not registered. And if they are banned or withdrawn, then we do have alternatives of chlorpyrifos and dimethoate. I would like to add here that for a sustainable pest management, we should lay more stress to the post-plant resistance. So we should focus on our research work on the varieties resistant to target pest in a particular region, say aphids in India. So if we can develop varieties with high levels of resistance, then we can manage the pest. And at least if we can breed varieties with moderate levels of resistance, even then also we can manage the pest and we can significantly reduce the application of insecticides. So that's my point, that we should not always focus on high levels of resistance. Even at least we find some moderate level of resistance also, then we should release those varieties. They can significantly help in reducing the insecticide applications on the crop.
Yeah.
Thank
So I'd
you.
like to come back to your really interesting work on Fruticulosa, maybe in the breeding session when we talk about that.
Okay.
But yeah, I mean, growers want to use insecticides because it's easy. So they want to replace those insecticides with magic cultivars that don't need insecticides, you know, because it's easy. But then you said in your presentation that farmers will go into fields and they'll physically pick off the infected racemes that are infected with aphids, which is, you know, an enormous physical effort to do that. So, you know, the two don't kind of add up. And I wondered if you thought that, you know, if farmers are willing to do that, then surely, don't you think that Indian farmers would be more willing to adopt strategies like trap cropping or intercropping, strategies that take a little bit more effort than just spraying insecticides? Do you think that might be true?
First, I would like to add here that most of the farmers in India, they are smallholder farmers. And the field size is very less, very small size fields. So this kind of strategy, I have told in my presentation also, that this kind of strategy is effective early in the season when populations are very low. And farmers, they are smallhold farmers with small land holdings. So this kind of, you can say, plucking the inflorescence and destroying them, it's quite feasible at small scale level. Although in Canada and other where they are broad acre canolas and grown on large areas, so this kind of strategy may not be feasible. And one more thing is that in those areas where fields are available early in the season, early planting is very useful. So this significantly reduces the pest population. It you can say it can lead to asynchrony between the peak aphid population and the flowering of this oilseed brassicas. So this is another very important point, that farmers, if the fields are available early in the season, if they are not in cotton fields, so we can go for early planting and simply we can escape the crop from attack by aphids.
Okay, that's great.
For insecticide application, practically just one application is sufficient in India to manage aphids. So by the time second peak of aphid starts, the crop is already mature and it's near harvesting. So if we can avoid that synchronization between aphid population with the peak flowering by manipulating the sowing date, so we can avoid that application as well.
Okay, well, thanks, Sohan. That's really that's great answer. Shumin Hao, are you there? Shumin, I'd like to go to China now.
Okay.
Fly across to China. Are you there, Shumin? Can you switch your microphone and your camera on if you're there? I'd like to ask a question about there's more pests than aphids in China, and I'm just interested to know if the Chinese are more willing to adopt alternatives. But I can see that you've got your microphone off, Shumin. Can you speak to us?
I see that Shumin has microphone on, but we can't hear.
Yeah, no,
So
another one
maybe
that's there but not there. Micah Brandes, are you there? Are you back from your tea break? No, never mind. We try very hard. I'm very trying, my grandma tells me. Okay, so I'm going to leave the crop protection there because there's quite a few questions on genetics and breeding. And of course, Maxim Hervé is another one that's not here, and unfortunately his replacement, Anne-Marie Cortizio, is also unable to be with us. But I know that there's quite a few people in the call that that do know about genetics and breeding. So let's have a go. If you think you know the answer, then just raise your hand and chip in. Because I think everybody seems to want, you know, resistant varieties. So we need to talk about this. Mahesh Gupta asked, first of all, what morphological, biochemical or genetic mechanisms are responsible for insects in Sinapis alba? So Sinapis alba seems to be the thing at the moment. It's resistant to most of the pests that, you know, it's been tested against. Can anybody talk about what morphological, biochemical or genetic mechanisms are responsible for this? I don't know, Boyd, if you're able to say anything about that. I mean, the white mustard is hairy, isn't it?
Yes, that was my go-to.
Glucosinolate profile. Yep. So.
Yeah, and then I know with cabbage seed pod weevil, the biomarker Maxime Hervé was talking about was a flavonoid, a very complex compound. But it's interesting you say that it's all the rage at the moment, because, you know, here in Canada, it was 10 years ago as well. I actually spoke with Dr. Lima Cott, who was a breeder at the University of Guelph in Ontario, now retired. And she actually, when I was wanting to do some more work on this, she told me that all of her lines were sold to a European company. But that's the last that she knew of it. The university had sold them to a European company. And so I was kind of curious if anyone in Europe has actually heard of it, or what. She wasn't even sure what company it was when I was trying to track down some of these original lines that were tested. So it's really interesting to hear about all this work being conducted in Europe at the moment, because right now there's very limited work in terms of insect resistance breeding here. Yeah, here in Canada, we're just still focused mainly on diseases, but hopefully that'll change.
Okay. So yeah, I guess that's what we need to find out. You know, because it's resistant to so many different insects, we need to find out what the mechanisms of those are, and then we'll be able to find, you know, bio-assisted tools to do that. There was a question about the lack of reliable field tests and bioassays is a major bottleneck to finding genetic solutions. You know, how can we improve this situation? Well, one way is to do bio-assisted markers, but it's, you know, it's easier said than done to find them in the first place, and that's obviously what Maxim has been trying to do. I don't know, Dr. Alba, Bernd Alba, we've got other people that are working on breeding. Your group has done some really interesting work on integressed lines. I don't know if you want to make a comment about how that went and it's why that didn't continue, perhaps. If you're there, I don't know if you can switch Bernd Alba on. In the meantime, Wolfgang, you've got your hand up. Maybe we. Wolfgang, can you unmute? That's it.
Okay, yes. Yes, I have been following this work a little bit in the past. There has been a lot of intergeneric hybrids being created with the hope to transfer respective genes from Sinapis, for example, into Brassicas. And that was in a way successful, that they created hybrids and addition lines, Brassica napus lines with additional Sinapis chromosomes. But I'm not sure that this really led to real Brassica napus types with certain genes, relevant genes just added from Sinapis genome. So I guess the major problem here is the genetic distance between the two species. They are just too distant, so that it will always be difficult to transfer genes from this other genus into Brassica. I may recall that, or remind you that even crosses between Brassica oleracea and Brassica rapa are difficult in that it takes very long time to create useful plant material from such inter-specific hybrids. So it's very difficult and very long-term approaches, of course.
Okay, I think we've got Janetta and did I see Nadine Ostal just come onto the call? I don't know if either of you.
Hello everyone. Hi, Sam. I'm from Poznan University of Life Science, and I would like to say that, of course, we are doing here in Poland also phenotyping and trying to obtain some Brassica pest resistance cultivars, but of course, like we know today, it's very time consuming and very problematic and challenging, as Maxime told us during his presentation. So I personally was trying to assess many of obtained hybrids, Brassica hybrids, and as well over 50 Brassica napus cultivars. But unfortunately, during many years of phenotyping and field trials, we were trying to obtain varieties with resistance to cabbage root fly, because it's in Poland very popular insect. And unfortunately, we were not possible to find during our years of work resistance, but in Sinapis alba. But we were trying to find, and we found resistance in Brassica carinata, for example, and promising looks like in Brassica fruticulosa it will be also possible to find some resistance. So that's all. But of course, it's, as we all know, it's challenging because phenotyping it's very time consuming. Thank you.
Absolutely. Rod, sorry, Rod, can we hear you? Can you? Sorry,
I'm
Nadine,
not sure if you can hear me. Can you hear me?
Hi, Rod. Yeah, we can hear you.
Okay,
Hi.
yeah. I just wanted to come back to what Wolfgang said, and maybe I don't have an answer, but maybe just another question. I was also very impressed with the presentation about breeding and genetics, especially the remark that Sinapis alba seems to have resistance to everything, and is a very interesting potential donor for resistances. But as Wolfgang said, it's been a long time since people started working with Sinapis alba and trying to integrate any traits into Brassica napus and other brassicas also. And as far as I'm aware, there are very few, if any, examples where actual chromosome integrations have been achieved from Sinapis into Brassica chromosomes. And I'm just wondering what the best approach is if we want to use that kind of resistance for canola breeding. And there are two things which could be possible. So firstly, do we need to focus on chromosome engineering and coming up with really new ways in order to break up bits of Sinapis chromosomes and get them into Brassica? So it's more of an, as I said, chromosome engineering approach. I know there are French groups who are very advanced in this, and maybe this could be one option. It's of course long term, but just wondering if if it will be the slowest way to do things, or if there's any other faster way. The other option, which I do see, is maybe focusing on genetics in Sinapis in order to identify the responsible genes, and trying to use then gene editing approaches or maybe GM to get these into canola. I'm just not sure which will take longer, the chromosome engineering or the regulatory hurdles that we have to get over in order to use GM or gene editing, at least in Europe.
Yeah.
So at least there are potentially methods in development, and yeah, I don't know which one to choose, but maybe there are experts on the call who might like to share their opinion.
Please put your hand up if you're an expert or not. If you've got an opinion to share, put your hand up. Andreas, you've got your hand up.
Oh, sorry, it's again me, yes. But I would like to briefly come back to what you talked about, the approach which Bernd Ulber has taken in Göttingen, and they try to find a relationship between glucosinolate patterns and resistance to insects, I guess, mostly, and they found some lines which were better than others. Was one little success at least. But my point is a different one. I think besides the challenge of establishing powerful screening methods, which is clearly one of them, and besides the second challenge to find resistance genes in nature or in the Brassica gene pool, which are rare, I guess, I think the third challenge is the question, how to design a resistance which will not be overcome very quickly by these insects once it is established in a cultivar. And I guess that's something we have to talk about from the insect's perspective. What is the kind of resistance we need to establish in cultivars which would avoid somehow fast adaptation and to be overcome very quickly? After many years of extensive work and efforts, you would find that it's broken very soon, because insects are very adaptable, and they can overcome these things. So do we have any idea of how this resistance should be shaped and designed to avoid that problem?
I think the Australians have a wonderful system, don't they, for resistance management to their, is it the Australians or is it the kind, I can't remember, one of you guys.
I'm talking about cultivar resistance, so not insecticide.
Well, they grow a resistant variety alongside you know, an area of a non-resistant variety, and you have to have that. It's Canada, isn't it, boys?
Sam, yeah, I think you're talking about wheat midge here in Canada, where we have a refuge in a bag.
That's right.
So we have to grow susceptible. 10% of the crop is, or yeah, pretty much 10% of the crop is susceptible, and 90% is I guess we call it tolerant.
Okay.
So that's a potential option, but I guess it also depends on, that is an R gene related resistant trait. So I guess it would also depend on the type of resistance that we're dealing with. But,
yeah.
And just to jump in Australia, we had the similar refuge strategy for BT cotton.
That was right. I knew I was thinking of, both ends.
If I may add one other challenge, I think from the German or European perspective, a cultivar with a single resistance to a single pest would not really help, because it would still mean to use an insecticide. So what we even need is a multiple resistance. So that would be the next one. When we are talking about reducing insecticide use, at least, that's another one. I don't know how about the Sinapis alba, these flavonoids, which were mentioned by Maxime Hervé in his talk. How specific they are acting on insects. I don't know if anyone knows that.
We did have an answer from Nadine. Unfortunately, she's not able to unmute her microphone, but she just wanted to add that she's working with Maxim actually, and that they're looking at chemical markers in Sinapis alba. So they're having a look, and they haven't got anything to publish. They haven't got anything published yet. So maybe watch this space. For chemical markers for Sinapis. That looks really interesting. So
I just see Rod is mentioning in the chat that maybe hairy rapeseed would be maybe more unspecific and
durable.
Durable.
Maybe it is tolerance rather than resistance.
Okay.
It's that question as Maxim posed himself, isn't it? Which is more durable. We've got a comment from Sarwan as well, that here in India we have refuge strategies for cotton. And the cotton comment actually comes back to, I can't remember whose comment it was, about why don't BT strategies work in rapeseed. Of course, the answer to that probably is that they work on Lepidopteran pests, and most of the pests in canola and rapeseed are Coleopteran. But I guess you've got diamond black moth and things like that. So maybe, I don't know, maybe there's a need for that, but yeah, it doesn't seem to be the way that things are going at the moment, do they? So yeah, let's watch this space on Sinapis alba. I know, Lucy, I don't know if you're on the call, but John Innes Research Centre in Norwich in the UK are also looking at there's a new PhD student looking at diversity and resistance in Sinapis. So I really think this is going to be a really, watch this space. You know, we can have a session on this in Sydney conversation. So I'm going to move away from genetics and breeding and onto the agronomy. Celine, are you there? Can you switch your microphone and your camera on?
Yes, I'm here. Hello.
Because we've talked about how you know, agronomical methods can actually protect resistant cultivars when we've got them. You know, we can protect them by using agronomical methods. And your presentation on how we can use agronomical methods to prevent the problem in the first place, you know, is a key component of IPM strategies. And it was just full of wonderful ideas of all the different things that farmers could do. So it's really, I really enjoyed your presentation. Thank you.
Thank you very much.
Krista Pearson had a question for you. And he was interested in the avoidance of escape. He said that it's one of the most important strategies to avoid insect attacks in Northern Europe. Winter oilseed rape is less attacked by pollen beetle than spring oilseed rape due to its early flowering. Can winter oilseed rape extend further north with more hardy varieties to avoid this? It's a bit similar to the question which was posed to Boyd earlier. Can the guys in Sweden and Norway avoid pollen beetle by growing winter oilseed rape because it flowers before the pollen beetles come? What would you say to that?
Maybe they have to try. What I can say is that in France, for example, spring oilseed rape is more attacked by pollen beetle than winter oilseed rape. So in France, we cannot grow spring oilseed rape because of pollen beetles. So I don't know, maybe in the north of Europe, it could be a solution. I have no idea, but it's possible.
Again, it might suffer the same consequences that, yeah, it would take a lot of breeding effort to get hardy varieties that could grow that for far north. But who knows, with global warming, it might get a whole lot easier to do that. But there's different really interesting ways of combating the problem in the first place. I really liked the cultivars. You're calling them intercrops, but you don't crop the clovers, do you, or the legumes? You're not actually cropping them. They're dying off in the winter. Okay. Yes. So I wouldn't call it an intercrop because is when you're actually cropping, you know, you're getting a yield off both of the species. So maybe it's a kind of a companion cropping or a nurse crop or something. But I'm really interested in that. We're doing a little bit of research on that at Rothamsted as well. Do you think that the effect is mainly due to, you know, confusion of the pest and the increased biomass? It can't find it quite so easily, or do you think it's mainly due to the fertilization effects? I know it's both, but you know what do you think is most important in why that works so well?
I can't really tell you what mechanism is the most important. What we know now is that with these legume crops, the nitrogen availability for oilseed rape is higher, and so the winter oilseed rape growth is better. So it's one mechanism. We know it works. The impact, the direct impact on insects are not known. I'm not sure that someone has studied this. So we don't know. We don't know if there is a repellent effect on insect or no. But what we can see is that we have less larvae in winter oilseed rape when it's mixed with legume crops. But this second effect need to be checked in lab.
We had a comment from Mahesh Gupta, who was commenting on well, the possibilities for intercropping in Australia, and maybe he kind of posed the hypothesis that maybe intercropping works because of allelopathic interactions. Do you think that it might be due to allelopathy as well?
I don't know.
So there's a lot of research to find out, you know, the mechanisms of why it works, and then you can make it better. So there's a rich stream there, isn't there, to be tapped in the future. Hector, you have your hand up. Hi.
Yes, good morning or good afternoon. I had a question for Celine and a comment also. First, I'd like to mention that in especially in Saskatchewan and to some extent in southern Alberta, here in southern prairies of Canada, there is some interest in intercropping, and this is something that has been initiated more by the farmers themselves rather than by agronomists or scientists. And some farmers are experimenting with planting canola with field peas. It's an intercrop, and there are some growers that have been doing it for a few years now, and there are a few thousands of acres now. And there's even a name for this crop, which I was quite excited to hear. They call it piola, you know, peas and canola, piola. But no one has actually studied the insects and how they respond to these intercrops, which I think would be interesting to do. But my question for Celine was, have you done any work with the spring oilseed rape in France with intercrops? I really enjoyed your talk, and I see that most of your work has been done with the winter oilseed crop. Is there any work on the spring oilseed crops, and what intercrops could be tested there? Thank you.
Thank you very much. No, we didn't work on spring oilseed rape because in France we mainly have winter oilseed rape, so we never tried on spring oilseed rape. So I can't tell you if it could work or not. I'm sorry.
We've tried it. Hector. There's a farmer in the UK called Andrew Howard who tried spring oilseed rape and spring peas. So even though it's not kind of, you know, we wanted to call it piola too, because it's just sounds amazing. It's a lovely word, isn't it? Piola. And so we've actually taken that forward in our EcoStack project. So we've had a group in Germany who have tried to crop winter oilseed rape with winter peas with mixed success, it has to be said. The peas, yeah, they need to be sown actually earlier than you know than they were sown in the first couple of years. So it's still a very early stage trial and error stage. But yeah, I think that could really deliver some really interesting benefits for pollen beetle control, but also weed suppression and fertilization. And so yeah, I think there's a lot that can be done. Just to go back to spring systems and piola, there's a group in as part of the EcoStack project again. There's a group in Sweden and Finland in Luka, Sari Hillman, who's been trying beans, spring beans, and or spring oilseed rape with some success. So it does look like the mix is having some positive effects on pest control, but they've only just harvested the crop. So watch this space for results. But yeah, it does seem like intercropping certainly could help as a pest management strategy.
Some of the farmers in Saskatchewan, they suggest that they're seeing less problems with flea beetles in the intercrop. So this is something to follow up, I think.
Yeah, yeah. Well, that really supports Celine's work, doesn't it? Yeah, there's something in that.
Good, thanks.
Albin, you've got your hand up. Hi, Albin Gunnarsson.
Thank you, Sam. Thank you for holding this session. I would like to give a comment on from Sweden when it's about spring oilseed rape and winter oilseed rape. Sweden is a country where we increase oilseed rape, winter oilseed rape production quite dramatically the last 10, 15, 20 years. And we also lost nearly all of our spring oilseed rape because of the ban of neonicotinoids. But we have always had a very distinct border between a mixed border between summer and winter oilseed rape. And there we get the pests problem. We get like 4 generations of pollen beetle. And now we see how this border moves north in Sweden, where we can now when we can expand winter oilseed rape production, and it's moving more north. And today we have problems with pollen beetles in our northern part of the cropping region, where we have a mixture between winter and summer oilseed rape. We had those problems further down in Sweden before, but we have much less problems with pollen beetles in our major area of winter oilseed rape. So it's I believe it's much more important to have these crops apart from each other. The mixture is a problem. It's more applications, more resistance problems.
Yeah, yeah. The winter and the spring crops, you mean? Yeah.
Yep. Yep.
Yeah. So I think crop rotations and diversity is definitely something that we need to remember, isn't it? We need diversity in the system. Boyd's got a comment that hopefully, there'll be some more research on that in Canada as well. But yeah, we at Rothamsted, because I work on pollen beetle, I want spring oilseed rape to work on. So we're one of the few places in the country that has spring oilseed rape and winter oilseed rape every year. Growers don't normally grow spring oilseed rape in the UK unless their winter crops fail. And yeah, we did a study across growers across the UK, and we found that Rothamsted has 4 times as many pollen beetles as most other farmers in the UK. And I think that that's exactly for the reason that you say, that we've got both spring and winter cropping going on at the same time. And yeah, this is probably something that we should really be thinking about not doing. Yeah. Andreas, you've got your hand up as well.
Yeah, I just can confirm that this is in our region, it's impossible to grow any spring type oilseed rape because we have our winter type, and you're overrun by pollen beetles. We tried it once in order to establish an experiment with verticillium, and it was completely destroyed. It was impossible. We sprayed every 3 days. It was not possible with whatever you could use as chemistry. It was not possible to control the beetles. But I wanted to ask a question to Celine Robert, because as a plant pathologist, immediate question comes into my mind when I hear about the mixture of oilseed rape with legume crops. That is, the name is sclerotinia of that problem. How about that? This is a wonderful stage for sclerotinia, what we are establishing here, isn't it? On the long run, at least. Do you have any experience with diseases being transmitted among those species you grow together?
No, not with sclerotinia. We are more worried about problem of Aphanomyces, for example, on pea, on legume crops. But for sclerotinia, no. I never heard problems
But do you have Sclerotinia as a problem basically in the pure oilseed rape stand?
Yes, yes.
You do, okay.
Yes,
and you don't see a significant increase when you add another host crop like a legume crop.
I don't know. I can't tell you. Sometimes we have Sclerotinia in the crop, the pure crop, but it's 1 year every 10 years, and the harmfulness is very, very important. But we don't have Sclerotinia issue every year, so I don't know. The problem would be more important with legume crops.
Yeah, I think so. Yeah, on the long run at least, and in years where Sclerotinia is strong. Yeah.
Interesting. Yeah, I think so many things that you need to consider. You know, you work on one problem in isolation, and then you disrupt the system and you find a new problem. But I was interested in the work on your novel novel technical system on preceding crops, and really finding the importance of the preceding crop on the yield of oilseed rape. And you came up with barley and durum wheat as being the best preceding crops. Do you have any reason why that is?
There are crops that are harvested early.
Yeah.
So it's possible to sow winter oilseed rape very early in August.
Yeah.
And with durum wheat, we also have more nitrogen in the soil. So nitrogen is more available for winter oilseed rape.
Okay. I thought, we're in Europe. I think there is a move to grow so earlier and earlier and earlier, and obviously, you really need an early harvesting crop to do that. So that makes sense. But the nitrogen makes sense as well. Very interesting. Does anybody else have any questions for Celine? Oh, we've got Xavier Pinche has answered a question to answer Andreas. No Sclerotinia for the moment during autumn. Legumes are susceptible to frost. I was wondering the same thing actually. So they're destroyed. So they're not present at the main time. Yeah. So there's no change no chance, I think it's supposed to say, for the spring Sclerotinia epidemic. So I think the fact is that there's a load of dead beans there by winter time.
But you were talking about winter peas. How about them?
Well, in a Piola system or an intercropping system, that probably would be an issue. And some farmers, we're getting quite a lot of undersown systems where farmers are sowing directly into clover stands, in which case I would call that intercropping, because the clover itself is harvested as well, and it stays there all year, so it doesn't die off over winter. It remains there throughout the growing season of the crop, and indeed it stays there for the wheat crop that follows it. So maybe the Sclerotinia might be an issue in terms of intercropping these crops that remain there beyond harvest. Anne, you've got your hand up, and Charlotte. Can you turn your microphone on and your camera? Hi.
Well, hello, everybody. I was now finally on the panel list, so I could get into the meeting. Thanks a lot for a very interesting session. Hello, everybody. I just wanted to tell you all that we are having an intercropping project in Sweden. We are very inspired by the French achievements within organic winter oilseed rape, and we're checking different legume crops on the prevalence of the flea beetle. We are also looking into the root pathogens of the legume crops, so we can tell the growers if there is a risk of multiplying, for example, Aphanomyces. when they are growing fewer crops later on.
That's interesting. Whereabouts in Sweden are you based?
Yeah, I'm based in the south center, about 200 kilometers south west of Stockholm, in Örebro. But these experiments, they are performed in in this area, in the very south of Sweden, in the Skåne, and also in intermediate in the area of Linköping.
Okay, so it would be really.
So they were just planted a month ago, and we got a tremendous amount of rain. So I think also that this intercropping helps rape the plants to grow, because there are other plants taking care of the water. So we'll see.
Be interesting to see the results. Thanks.
Sam, I think this is a good moment to go back to your second question. Can we grow rapeseed without insecticides at this moment? I guess because Celine has shown so many tools which could replace or could at least relieve the pressure on using insecticides. And it was also my question to her. Do you really think if you even have an optimized IPM system in oilseed rape, you do everything in the best way you can do it against any economic reason? Would that be a system which could be run without insecticide under current conditions in oilseed rape? Is that possible?
Sometimes it can work.
Sometimes, okay.
Only sometimes. The problem is that you can have. It depends a lot on the climate, also.
And the location, yeah.
In the location, in the duration of winter. Sorry, if the plant is able to grow early in spring, we saw that flea beetles' harmfulness was lower. But in some French regions, for example, in the east of France, now we have a winter that is longer and longer. And even if all these agronomical techniques, we are not able to manage flea beetles. So in some areas and some years, it can be enough, but it's not always enough. And I think that we need insecticide for these situations.
Yeah,
thanks.
Absolutely. Right, we've got a question from Hector about bees. So, has anyone got any more questions for Celine on agro-technical matters? If not, have we got bees? I can't find her. There she is, Sandra Lindstrom. Shall we go to bees? And,
yes.
And ask a few questions about bees. So again, Celine found that this really interesting increased yield where you had lots of diversity and in rotations that were very diverse. And I wondered if that had something to do with the fact that the ecosystem was healthier and that there was more bees. I don't know what you think about that obviously more diverse habitats will benefit bees, which will benefit the crop.
Yes, of course, because in a diverse crop rotation or in a system, you get variation in the flowers that are available, and you get potential more nesting places, and also bees can potentially avoid pesticides if there is a bigger variation within the landscape. So yes, variation is key for promoting biodiversity, and especially diversity of bees, no question about it.
Okay, there was a question from Maresh Gupta who said, in your talk, when you found actually 7% higher oil content in crops that have been pollinated by bees. Do you have any reason or explanation for this increase in quality?
Well, first of all, I would like to stress that this is a single experiment. I don't know of any other experiment in winter oilseed studying this. So it should be interpreted with caution, of course. But and also we need to do more mechanistic studies for this. We need to involve more competence of oilseed rape competence, because many of us working with insect pollination in oilseed rape are landscape ecologists with great insight in insects and pollinators, but less insights in agronomy. So there's a need to do more research about this. But what we suggest to be a cause of this this pattern that we found is that increased pollination could give an increased cross-pollination, which in turn could increase heterosis and thereby potentially increase oil content in the seeds. But I mean, that's just something that we don't know really.
Yeah. Okay. Wolfgang, you've got your hand up. Have you got a comment that relates to that?
Didn't you say that the yield effects were larger in open pollinated varieties than in hybrids? And also
yes.
You had this difference between the genetic system and the cytoplasmic system. So maybe it's too early to say that in the light of what you said before. Would you recommend to avoid to come back to breeding open pollinated varieties instead of hybrids? I mean, the trend is clearly versus hybrids, and I would assume that this would be going to continue.
Well, my personal opinion is that we will always keep open pollinated cultivars because they're the basis of the breeding. But I think that we shouldn't forget about them. And I think that we need to integrate pollination in our cultivar trials, so that we compare the cultivars on equal terms. Can I say that? So that because today pollination is seldom considered in cultivar trials. So and in our study we found in 2 studies that open pollinated cultivars had higher yields than the tested hybrids. So if we want results that are valid also under high pollination conditions, we need to test the cultivars under these conditions too. And then there's of course other aspects of open pollinated versus hybrid cultivars, because there is a possibility for farmers to harvest their own seeds with open pollinated cultivars, which is not the case with hybrids. So I mean, there's many aspects of it, but I think we need to start by finding out more which cultivars that depend on pollinators and which doesn't so much. And today there is a very limited information about the cultivars that are on the market. So the farmer, he cannot say, or he or she cannot say that, oh, I have plenty of bees, I need I can gain a lot of choosing a cultivar that gains of insect pollination. But that's not possible today.
That's a good point. Absolutely. Shumin Howell, you've got your hand up. Hi, Shumin. Can you switch your microphone and your camera on and ask your question, Shumin, or you'll make your comment? I don't know. Okay. If you can, then go for it, Shumin. Otherwise, oh, it's gone. Okay. Maybe it's not relevant anymore. Okay. I thought we were going to get an interesting Chinese perspective on that then. I know in China, yeah, they're having big problems with pollination, aren't they? A lack of pollinators, absolutely a lack. So it's something that that we should think about with oilseed rape. And oilseed rape's got such, or rapeseed's got such bad press actually at the moment because of the neonicotinoid issue that, you know, the crop is poisoning all our bees, and you know, actually it doesn't take much to do some research to think about how the crop could actually provide an even better resource for it. And I'm sure some of the reductions in honey yield that people have seen is actually because there's simply less of it grown than there used to be, never mind what cultivar it was. We've got a comment from NPZ. Of course, they're saying GMS hybrids, we prefer that those should be grown instead of OP. Yeah, I mean, open pollinated GMS hybrids were very, very high in nectar compared to OP varieties. Also, I guess the hybrids are more vigorous, as Celine said, vigorous in establishment. And if you're thinking about, you know, cabbage stem flea beetle pests, then you might want to think about a hybrid instead of an OP cultivar. But yeah, there's such a lot to think about, and maybe your point is it's not just about yield, and if farmers going for yield, then it's not a level playing field in terms of how those cultivars are portrayed. I just was blown away by your results that crops that had received insecticides received, you know, more bee visits than those without, that the crops were healthier and that they yielded more. And you might think, well, that's because the insecticides worked. So
yeah, but I have to correct you there, because we didn't look at yield. We had a massive sclerotinia infection in the field, so we weren't able to evaluate yields. So that someone else has to do that connection. Yeah, but it was very clear and dramatic results. And we even saw that bees visited oilseed rape flowers that were sprayed against pollen beetles. They did more visits. They stayed longer on the flowers and did more visits. And if you open an oilseed rape flower infected by a pollen beetle larvae, I mean, they could destroy the buds and destroy the flowers. That's one point. And they could destroy the nectaries producing the nectar. But if you open a perfectly fine oilseed rape flower and there's a pollen beetle larva inside, you can see it lays along the stigma or the pistil. Mm-hmm. And I wouldn't be surprised if it feeds on nectar. And also blocks the way for the bee.
Yeah, I think it does. Gaetan Simandikorda did some nice work on that and showed that pollen beetle larvae do indeed feed on nectar. And yeah, the way that they position themselves in the flower suggests that. And I guess that, yeah, bees learn, I guess, that that flowers that have got these annoying insects in them, you know, then they're harder to handle than flowers without. Actually, my PhD supervisor did an interesting experiment where she just put black dots to mimic the adult beetles with a marker pen on the flowers, and found that those black dots actually reduced the visitation of flowers by bees. So it seemed that, you know, bees are quite repelled by pollen beetles, and yeah, the more we can do to control them without killing the insects, then the more we can do for pollination. Very interesting. Yeah. Anybody got anything else to? I'm going to ask this question that Hector posed, just because it's about bees. Hector asked, is there any work on biovectoring in canola or oilseed rape, using bees to deliver entomopathogens to manage pests? I've got an answer for that, but I'll let you have a go first.
Well, I gladly let you to answer that, because I'm not very I'm not very into entomobacterias actually. So.
Yeah, so it's one thing that we didn't have in this program is much about the potential for entomopathogens to control oilseed rape pests, but there is of course quite a lot of work that's just ongoing with that now, against pollen beetle, against cabbage stem flea beetle, and years ago I did a little bit of work with Heikki Hokkanen from Finland on using entomopathogens to control pollen beetle, and we found a strain of Metarhizium that was used that would work quite well against pollen beetle. I know the Swiss group in AgroSect also have found strains of Metarhizium that are very active against pollen beetle. And we used the trap cropping principle to test out whether or not bees that would be attracted to trap crops because they're flowering. So are the pollen beetles attracted to trap crops because they're flowering. So the bee takes the entomopathogen to exactly the place where it needs to be in the flower. It was a fantastic idea, but it didn't work because basically we collected thousands and thousands and thousands of pollen beetles and none of them died. We tried it in cages and it just didn't work very well. But so the answer to your question, Hector, is yes, they've tried it, but they need to do a better job than I did. I didn't even publish it because it was just not good enough. So
was that the entomopathogen was not effective against the pollen beetle then? Possibly.
Yeah, I think so. Or the bees just didn't spread it well. It maybe our bee dispenser. I mean, it's quite some technology there really in making sure that the bee is correctly dosed. You know, it needs to, the entomopathogen needs to be on the bee where, you know, where it can transfer it to a flower. You know, it's quite a technical thing, and maybe the bee dispensers that we used weren't quite as good as they could have been. But yeah, I love that idea, Hector, and maybe
there has been a little bit of work here. Well, not in the prairies, but in Ontario, they have done some field work and in cages. Of course, in greenhouses, they're using these a lot, and they're using bombos to deliver entomopathogens for Lygos, twitch, and other things.
Yeah.
But there is some interest in using it in the field in canola, and I am curious whether I could kind of what you did with the trap crop is exactly what I was thinking about doing with. We do have a method using a trap crop, planting Polish canola on the border and attracting Tabecipor weevil there, concentrating it, maybe using bees to deliver something like Boveria bassiana, something like that. But it's a pretty large project to do and quite risky, but I think it would be interesting to do.
Definitely, there's definitely a grant proposal there. So do you think, so basically, Sandra, you think that growers have got, a potential to increase their yield? So we've seen a yield decline because of pests, but basically, if we think about pollinators, we have the potential to at least alleviate some of that decline through improved use of pollinators.
Well, at least I think there's enough clues to work more on this, because there are the results that we got from our landscape studies was that there was effects of 10%, about 10% in the open field landscape study in Sweden, and about 19% in Italy. And I mean, that's a lot in increased yields. And I mean, 7% higher oil content, that's a lot too. So I think we really need to work further on with this. And I'm afraid that it's a bit too early to implement pollination, like as a cropping method that gives you a 10% return. We need to know more about it before we can like recommend it to growers.
Yeah. So I want to go now on to the crop protection 2 part, because I think Sandra's point was that, yeah, we need, you know, to enable bees to do their job properly. They like nice clean flowers, which means that they need insecticides that don't kill them. And the crop protection 2 part of the program was really focusing on the availability and the development of some alternatives to synthetic insecticides. And we started off with Hector on some really cool work on biological control and conservation biocontrol, you know, basically introducing an insect that isn't currently there, native to that country, and trying to see if it can be safe to release that. Hector, do you want to come back? Yeah, hi. So I really enjoyed your presentation, and I'm so glad that you know, these safety considerations are being thought through, because obviously releasing organisms into the environment can sometimes go catastrophically wrong, and there's some, you know, amazingly hilarious examples actually in the literature of where it's gone wrong. So would you like to tell us a little bit more about that? I was curious that you know, Trichomelus perfectus, obviously we have that in Europe. It's very highly effective parasitoid of seed pod weevil in Europe, but it made its way to Canada. Do you know how it got there? And if it's already there, is there a need for, you know, such stringent safety measures to you know, to basically reintroduce it to another part of Canada?
Well, that's an excellent question. Your first question, how did it get there? We don't know. Okay, somebody will have to do some population genetic work to try to figure that out. But we are happy that it's I guess it's a welcome invader to Canada. It's in Quebec, and it was reported also in Southern Ontario. It's not as well established in Southern Ontario. The parasitism levels there are not that high, but in Quebec they do have very high levels of parasitism in some fields. It's not in all the fields. And one of the goals of this project was also to relocate it within Quebec, and that is not an issue within Quebec. You know, it's one jurisdiction. The ecosystems are more or less similar there, the habitat, so they are going to relocate it to areas where the farmers do not have them. But moving it from Eastern Canada to the prairies, that is a completely different ball game, right? It's we have vastly different ecosystems. Our species assemblages are very different. So I think although legally we are not required to actually do this work, as you mentioned, you know, there are really no laws that would prevent me from going to Quebec or asking Jean-Pierre Labrie, send me some Trichomalus and we'll release them here. If we wanted to, we could do that, but it's not really recommended because we have such a different ecosystem. So I think our environmental conscience and ecological conscience, you know, suggests that we should do these experiments and at least have some ideas about potential impacts on our native weevils here, and also any potential indirect effects with parasitoids. And so far, it's looking like there are not that many native weevils that are at risk in the prairie. So that, I think that's good news. We do have one weevil that is very common here, the Cytorhynchus neglectus. But in fact, our colleague Lloyd Dostow, now deceased, as you know, he actually suggested that could be a bit of a minor pest in some of our canola fields. So it might be not a bad idea to have some level of control on that weevil. So I think the risks are not too bad. There was a major concern about interfering with our weed biological programs because there have been some species that are related to Cytorhynchus that have been released to control weeds in Western Canada. But the good news there is from the work that Tim Haye has done in Germany. The parasitoid, as you all know, it's going after the weevils in Brassicaceae crops, and particularly those that are in the seeds. So there is a niche there that this parasite is exploiting. So again, I think the risk is going to be fairly low. So we're optimistic that we can write a petition at the end of this project cycle and be able to relocate it to the prairies, and hopefully we'll get established, which I guess is the other big question. It's not very clear whether we actually have the exact climate matching, but we do have some regions where it should establish and hopefully increase from there.
It's really interesting. Obviously, Canada is such a huge place. It's almost like taking it from, you know, from the UK and putting it in probably Russia or something like that.
Yeah,
So
exactly.
it's a very obvious point there, but I thought it was worth making. And also, it's not just about climate, is it? Because you know, we don't really know that much about the habitat that parasitoids need to survive in the environment. So, you know, what do you know about the habitat requirements of these two parasitoids, the one for the lygus bug and the seed pod weevil? Do you know what they need in the environment to survive, that you could maybe make sure there's more of it than you've got in your area that will help it to survive and thrive?
No, the short answer is no. There are some works on landscape ecology that people are doing, and hopefully that might give us an idea. For example, we had a student working on cereal leaf beetle and its parasitoid, and we know that overwintering habitats are important. And for example, having tree shelters or having water bodies next to the farms that provide some ideal habitat for overwintering for these insects. We don't know that for these insects. Hopefully we'll get some information as part of the studies, because there is work on landscape ecology in Quebec, and also we have a student in Lethbridge who is also doing some work on landscape ecology, and hopefully we can identify that and at least release them in the areas where they have the best chance to get established.
Yeah, at least climatically. We're doing quite a lot of work on that at Rothamsted at the moment. We're trying to really understand what what the natural enemies of oarseed rape pests need in the environment, and then give that to them, because obviously most of them are specialists. So it's not that easy to maybe give them what they need to survive in the environment. And there's a lot of work that needs to be done to maybe, develop bespoke field margins or bespoke areas that will help these parasitoids to survive in the environment.
Right. We know a little bit about, I guess it's not related to canola, but for the parasitoid of the cereal leaf beetle, Tetrasticus julis, there is some work that has been done showing that if you supplement the field with some nectar, spray some sugar on the field, you actually get good results and can extend the longevity of the parasitoid. And incidentally, if I may mention this, our student who did the study on landscape ecology for cereal leaf beetle, he found that if you have more canola around the cereal fields, you actually had better levels of parasitism, and the parasitoid did better. So it looks like canola is providing some of those resources for this parasitoid of this cereal pest.
Yeah, so let's not forget that. I mean, that's basically what Sandra was saying, that oarseed rape's a wonderful pollen and nectar resource for many different flower visiting insects, and I think, insects love oarseed rape, and we should make the most of it to help the farmers, to help the insects help the farmers. Do you think that the levels of parasitism that the parasitoids exert, it can be enough to reduce insecticide use?
Well, in Quebec, they are finding that where the parasitoid has increased to high levels, and they have more than 50% parasitism in some cases, that the farmers have reduced the use of insecticide, and that's one of the reasons why we got excited about this. They have seen that trend where there is more parasitism, there's actually less insecticide use, so that's quite appealing. Of course, we never rely on one magic bullet, right? We want to integrate with other strategies and maybe convince farmers that they should use more trap crops and move towards intercrops. And I think once we have a better combined, more integrated approach, we have a better chance of reducing our dependency on insecticides.
Excellent. Well, let's hope for that then. That's great. Thank you for that. Have we still got Perrin Scott? Have we got Perrin Scott Ross still? I can't see.
Yes, I'm here.
Oh, hooray, hooray. Oh, there you are. I'd like to move on to your endosymbiotic bacteria and the potential for those to provide crop protection in rapeseed. So really interesting. I mean, it's very, very kind of fundamental research at the moment, isn't it? But do you feel good that it might provide some real alternatives for oilseed rape or rapeseed growers?
Yeah, it's very early days yet, but I think there's a lot of potential. I mean, the good thing about it is that it's species specific, so you're targeting a particular species, and there's a lot of diversity out there. So, I mean, endosymbionts are in a lot of different insects, and they have very big effects on their hosts. So, if you can manipulate that, then that could be potentially really beneficial, but you're sort of limited to what effects are already out there in nature, unless you genetically modify things. So in a lot of our research, some of the things we're finding are really interesting, but they're not always beneficial.
Yeah. And the question is, I suppose, if you've got to knock something out, but it's easy to knock out these endosymbiotics by antibiotics in a Petri dish, but if you were to spray that on a crop, you're going to knock out the endosymbiotics in everything. So how do you think that we could deliver, add things and take things away from the aphids, in a more targeted way? How do you think we can deliver this technology?
Yeah, so in terms of chemical treatments, you have to be very careful, obviously. But if you were targeting certain endosymbiotic bacteria, there are specific antibiotics that you can use that wouldn't affect the other ones. So the Buchanera that live inside aphids, they're susceptible to certain types of antibiotics and not others. But obviously you have to be very careful about putting things out into the environment that could affect beneficial insects as well.
But what kind of range of insects have Buchanera though? I don't know.
It's just aphids, basically.
For example.
No, it's pretty much just aphids.
Just aphid. Okay. Right.
Yeah, and each species of aphid will have a particular strain of that Buchanera.
Right. Oh, okay. That sounds good then. If it can be a species or genus or group specific insecticide, then that sounds really promising. Do you think it's going to be easier to knock endosymbiotics out rather than add them in?
Well, I think in the aphid species that we're interested in with our research, it's going to be easier to add them in. So in Australia, all of the so the green peach aphid, for instance, doesn't seem to have any of these secondary endosymbionts. And so if you put them in, then maybe they'll reduce their ability to block viruses, or they'll be able to be you can release those aphids with those endosymbionts, and then you can suppress the populations later on during a hot season or something.
It's fascinating. Has anybody else? Oh, Serena, hi.
Hi, can you hear me all right?
Yep.
Yeah, I just had a quick question to Perrin about, and you can totally rule this out, but if you're thinking about trying to make some of the antibiotics to knock out particular endosymbionts more specific, obviously plant expressed compounds are more specific because the aphids have to feed on the plants. Have you seen any evidence that people are trialing whether or not they can get plants to suppress antibiotics that are specifically for endosymbiont knockout?
I'm not aware of any of that. That's definitely something to think about.
Okay, thanks.
Cool.
Oh, so I'll just say one thing. So we've done my background's in mosquitoes, and so we've done a lot of work, similar work, where we're trying to stop dengue virus from being spread by mosquitoes. So we're sort of taking this approach that we've used, and we're moving this to agricultural pests.
it's the tech. It's just so cool. I love the idea, and yeah, I think there's a whole stream of research to follow that surely must give prospects for better control or alternative controls. So yeah, I'm sure you're onto something here.
Yeah, we'll see.
Yeah. Has anyone got any other comments about endosymbiotic bacteria? It's taken much longer to get through all the questions than I ever imagined. I kind of thought we'd have like an hour and then we'd have this discussion about these 3 things. And now we've got like 10 minutes left and we haven't even done RNAi, but I think we've lost Eve Veerman and Guy Schmeg. So Andreas, you've got your hand up.
Just a quick question to Rod, to Perrin. Is there any similarity to BT with that system? We know that BT is not acting on aphids as far as I know, but is there any similarity with endosymbionts with Bacillus thuringiensis?
Not sure if there's any interactions there.
No, any similarity, not interaction. Is it
similarity
in the way how they work and how they kill the insects?
Not really. Yeah, I think they're quite different.
Okay.
BT produces a toxin, doesn't it? A toxin, and
yes, it's a toxin, which is.
Whereas endosymbiotic, they're responsible for. Yeah. Do they produce?
Yeah, so
some of them though might produce toxins, possibly.
Yeah, they can. Yeah, but endosymbionts live inside the cells of insects. And so they're usually transmitted from the mother to the offspring. They're sort of like mitochondria in a way.
Okay.
Is there any way of preventing that transfer or preventing the transfer of, individuals to individuals?
Yeah, well, you can wipe out endosymbionts with antibiotics or heat treatments, things like that. So if you can, prevent that transmission, then obviously you can also remove it from the population. So if there's an endosymbiont in a pest that is making a pest species more of a problem and you can knock it out, then with an antibiotic or a heat treatment or some other environmental condition, then that's a potential way to control the pest.
But there's no way to prevent the mothers passing it on to the offspring, I guess. No easy way anyway, other than knocking it out, which will probably kill it in the first place.
Yeah, that's right.
Yeah. Wolfgang, sorry, Andreas, you've got your hand up again. No, oh, sorry. Okay. Maybe some RNAi methods of knocking it out might work, but if we've lost Eve and Guy, that could have said more about that. Shall we go on to RNA? I've got like 5 minutes left. Thank you, Perrin. It's really food for thought. I'm just really excited about your presentation and the prospects, and I'm sure. I hope that we'll hear from you in 2 or 3 years' time, and you've got some more to say and some really cool methods that we might be able to exploit this really amazing biology, really. So thank you. We haven't got Guy and Eve, but there is RNAi technology available. They both in their group developed a system for pollen beetle, which was fairly successful. And I know we had a question from, I can't remember who it was now, but it was for Boyd, and he's still here. I hope he's still listening. And it was about the flea beetle. Boyd, do you know that there is RNAi technology available for Phylotreta flea beetles? Do you know if that's a spray or genetic manipulated plants or both?
It is both. So researchers at the University of Manitoba, Dr. Steve Wired and Mark Belamonte have been studying it for a number of years now. From what I recall from the presentation, actually the sprayable application was more effective than the kind of systemic GMO version. I'm not sure if they're continuing with that or if that's now been taken over by a commercial partner. I know they've kind of shifted gears and now they're working more towards looking at sclerotinia and RNAi for sclerotinia also in canola. But I think, yeah, in terms of overall efficacy from their work, it was pretty successful, but not as high as some of our synthetic insecticides. So that's about all I can tell you about that at the moment. So.
Yeah. At the end of the day, you know, I guess certainly the sprayable formulation, well, both of them actually, they are just another insecticide, really. But they are, you know, if they are as highly species specific as they're supposed to be, then that is pretty awesome, actually. And yeah, maybe it does. That's going to be the new frontier of insecticides. You know, globally, if we get our heads around it. I guess there's two mechanisms of delivery: the sprayable formulations, or you know, genetically manipulated plants. Certainly, the latter are less likely to be grown in Europe. Somebody asked a question about that actually. You know, are people in Europe going to get their hands on this technology for GM plants that express RNAi? I don't know if anybody's got a comment about that. What do we, Wolfgang, Andreas, what do you think? Are we ever going to see GM in Europe?
Well, we just had our elections, as you know, yesterday or 2 days ago, and it's still unclear what the government will be about. But I don't think that GMs will be accepted. We can be happy if the new breeding methods will be, genome editing methods will be accepted. That would be a big step forward, I guess. But the traditional transgenics will be very difficult, I guess. Yeah. We can be also happy if RNAi as application of small double-stranded RNAs will be accepted. I could imagine that some people could occur and say, okay, that also has something to do with genes, although it's not the case. And you know how this happens. And once you have this kind of label on the technology, it's very difficult to get it off again. And it's even not clear and sure that will go through as a technology. This RNAi, and it was interesting to see the talk by Guy Magget to see how this will be regulated as a pesticide. So that is the lowest level we can expect, that it could be accepted like a pesticide accepted, but you know how well pesticides are accepted. So it's not easy. I don't know what Wolfgang thinks about it.
Well, I entirely agree with you. Maybe I'm a little bit pessimistic usually, but optimists will not change the situation, I'm afraid. And for the time being, we would have to get permission for RNA for CRISPR-Cas method, which is considered transgenic at the moment in the European Union. So this needs to be deregulated, of course, and that's what we have to work on, I think.
Yeah, it could be the new frontier, but I certainly don't think it's the answer to everything. So now I thought we were going to start our discussion, but it's actually, you know, 1 minute to go. So I just want to kind of wrap up really in the minute that we've got left, and just, well, thank again Wolfgang Friet for the opportunity for us to get together as a GCIRC technical meeting on insects. I hope we've shown you that there's an awful lot of research out here, and I really do hope that insects are going to, you know, have a big role to play in the next International Rapeseed Congress. I think we've got a lot to talk about. In terms of answering our questions, I think the answer, yes, I think a lack of synthetic actives is probably driving pest resistance in some species, but it's obviously not the case globally. And we've probably got, you know, we've got a lot of interesting discussion still to have on that question. Can we grow rapeseed without insecticides? Again, I think Celine answered that well, in that yes, we can, but it's difficult. And I guess the thing we need to think about is if we can't maintain the yield, then more land will have to be taken out of production to maintain the yield. And is that really what we want to have? So I do think insecticides, you know, do have their place in modern agriculture. But yeah, we could do if we had to, I guess, is the bottom line there. And that, you know, there are some really cool technologies almost there ready in the pipeline, like RNAi, endosymbiotic bacteria. It's just blows my mind with the possibilities what that could bring if we work out ways of delivering that. Alternatives such as, you know, trap cropping, and obviously biological control, both classical in the way that Hector is thinking about biological control, but also conservation biocontrol, which I'm very interested in. I think, you know, there's a lot of work that we need to do to understand the relationships between the crop agronomy and pesticide use and pest problems. It's enough to keep us busy for the rest of our careers. I wouldn't like to choose one of those. Maybe we should have a vote at the end, maybe in the chat, in the online chat, if we all kind of make a vote about what we think the most likely alternative technology to enable pesticide, rapeseed to be grown without insecticides. What's the most likely approach to enable that? What do we think that is as a group? That would be interesting if you can pop that in the chat. And yeah, what are the main barriers? Well, obviously regulatory was one of the major ones. But I think it's right that we should be careful, as Hector says. You don't want to be the person that brings the system down and some terrible unforeseen consequences. But obviously, yeah, barriers are quite large. And yeah, farmers, at the end of the day, farmers are going to behave in certain ways. We need to understand farmer behavior more in order to be able to implement some of these alternatives that are coming into the market. And so the work that Sabine's doing as well maybe feeds into that whole process. So IPM, yeah, it's got a lot of potential, but it's got a lot of work to deliver. We still don't really have a full integrated pest management strategy for any of the pests in rapeseed. So we've all got a lot of work to do. I really want to thank you all for coming to this session and for contributing to the discussion, asking some great questions. And yeah, we've got a lot of work to do, haven't we? And I really hope we get the opportunity to talk about our work in person at the next meeting, whether that's in Sydney or wherever the next technical meeting is going to be. Do we know where that will be held yet, Wolfgang?
That can probably be in India, but there are certainly a couple of alternatives too. So that will have to be decided on the occasion of the next Congress, I guess. And Rob Wilson will be the man then, new president, who's making this decision together with the board, of course. No. And
right.
May I take this opportunity, Sam, having the word, I'd like to thank you particularly for all your activity here, and that you accepted this difficult task, which you really did very well. I mean, no one of us could have done better, I'm sure. Thanks a lot for this, and we look forward to further interesting meetings together with you. Thank you.
All right, well, thank you. You all made it a pleasure. And yeah, I really hope to see you all in person, be it in India or Australia or online and via email. So thank you. And Have a nice afternoon or an evening or a morning, wherever you are. Take care.
Thank you.
Bye.
Thanks, Sam. Thanks a lot.
Bye.
Take care. All the best to
Thanks.
you.
Bye.
Thanks. Bye-bye.
Thank you.
Bye bye.